Yes, so I will talk to you about how to make it nice and easy to work with data. And the title of the talk is What Makes a Great Data Platform. So I'll talk to you about what I mean when I talk about data platforms. I'll talk about what I think makes data platforms great, and I will show you how we have implemented some of this in the product that is Twirl. Feel free to interrupt me whenever throughout with questions. I think the recommended way is to raise your hand or use the raise hand function, and I will do my best to get to them. So starting off, what makes a data platform at all? What do I mean by this? I mean sort of a framework and a system for working with data, or rather working with code to do things with data. So like transform data, process data, trigger automations, run predictions, prepare data for ML features, really sort of anything, commonly referred to as data pipelines. An analogy, I guess, from the front-end world is that if you're developing a web app, a very convenient way of doing so is to use a framework like Next.js on top of Vercel. So Next.js gives you a really nice way of structuring your code. And if you do so, you can run it on top of Vercel, and you don't have to worry about any of the mundane details of how things run and how things interconnect and work under the hood, and you can focus entirely on your web application, which is what you are supposed to do. And that is what you should expect out of a good platform, I guess. So what makes a great platform? I think one way of approaching this topic is to talk about what's happened in the industry over the past few years. So sort of, in my opinion, one of the most impactful things that happened was the entrance of dbt. So dbt, I assume most of you are familiar with. dbt is used to stand for data build tool. Nowadays, dbt stands for dbt. And it is a framework for working with SQL transformations, primarily in a data warehouse context. So this is a fantastic up-leveling of the user experience of working as a data analyst, or many aspects of working as a data scientist, if you work with code, because you get like a beautiful, structured, standardized way of working with code. You get a really nice way of testing your code. You get a nice way of packaging your code for production, running it, scheduling it, etc. So it's super nice, and it sort of really opened the eyes, I think, to a lot of practitioners in this space to what great feels like what's the vibe of being really productive and having a really nice environment to work in. There are other entrants now in the space, but like dbt really sort of deserves the spotlight here, I think. And dbt truly is fantastic if you are working with tabular data, if you have most of your data in one place, if you are happy working primarily in sort of batch mode or hourly or daily batches. And then if this is true for your environment, then life is truly peachy. Like it's really really smooth and really nice. But this is rarely where sort of the value stops. Like this is fine if you're, yeah, it's fine if these aspects sort of satisfy everything you need. But pretty soon you will want to do other stuff. You'll want to send Slack notifications with nicely formatted business reports to your finance department or something, or you'll want to push data back to your production app to serve to customers, or you'll want to send emails to customers that are about to churn, or you will want to process PDFs to extract unstructured data that doesn't fit well in a warehouse, or you want to call external APIs to get that data summarized or whatever it might be, or you want to do machine learning, or you want to do things that sort of also don't fit nicely on top of a data warehouse runtime, or perhaps you want to some of your pipelines to run with low latency. So you want to do fraud detection, and you have to get your predictions done with relatively low latency. And now life sort of gets complicated, and then you want to do things in different languages. Maybe you want to run Python in a container, maybe you want to run R, maybe Go, maybe C#. We have one customer that runs a lot of C# scripts in their data pipelines, and it's a perfectly valid tool. And we believe that a great data platform should basically not block you. It should let you use the right tool for each job, regardless of what that might be. So if you want to achieve these aspects, then suddenly dbt doesn't help you, or like suddenly you'll need to turn to an orchestration solution, and you'll need to turn to compute clusters and CI/CD systems and Jenkins and whatnot, and life is suddenly not peachy at all. And what I sort of want to convey is that it can be delightful. It really can, and I think it's some of you might have had the privilege of working at a big mature company that have invested like a lot of time in developing these kinds of environments in-house. And if you have, you'll know that it really can be quite nice. Like you can get an environment that is as easy to use and as nice to use as something like dbt, but that gives you sort of everything you need, not just warehouse-centric workloads. And another interesting aspect of this is that a lot of these platforms end up looking remarkably similar. So like if you talk to people at a few of the big mature data companies, you'll hear that all of their internal platforms have very similar functionality. So that's sort of the foundation story of Twirl, I guess. Twirl is that. It's a way to give access to, give any kind of company access to an environment that is unified and integrated and streamlined and sort of works well across all of these use cases without having to invest a lot in getting that right yourself. And that means things like Twirl works just as well with unstructured data or file data as it does with tables or tabular data, or really anything at all. Twirl lets you mix batch pipelines and low latency pipelines in one system seamlessly, so you can sort of relatively seamlessly transition from hourly or daily batches to running your pipelines more or less continuously or every 5 minutes or however often you like, or like as needed, or event-based. Twirl lets you not only use SQL, but really anything you like. So you can run real Python in real containers or Go, or again, anything that you can put in a container, basically. Which means that Twirl provides a really nice environment for mixing analytics and machine learning applications or automation applications in one system. Like you can do both. You can reuse the metrics that you built for tracking churn for analytics purposes, and you can reuse that to build a churn prediction model for buyer data science team, for example. And another important principle that we think is important for a good platform is that it should be easy to use and sort of provide good nudges and strong guidelines for how to do the simple things, but it should never block you. Like the risk with a framework that is opinionated and very that cares for you is that it will lock you in and sort of prevent you from doing what you want. So another design principle is that it should always be possible to break through the abstractions and do whatever you want when you need it, if you know what you're doing. And final slide before I show you the real deal is sort of just to paint an overview of what we typically what the typical stack will look like in our world. So the typical stack will look like some, or usually a few different places to store data on the bottom here. So like a warehouse or a lakehouse or a data lake or file stores or blob stores or whatever. You'll have various ways of getting data into your environment on the left-hand side. Usually things like terabyte or Fivetran, but also very often custom-made scripts and custom-made integrations. You'll have lots of ways of consuming data on the right-hand side, probably dashboards, but also hopefully endpoints that expose data back to your production systems or exporting data to other external places. And And then Twirl is sort of primarily focused on the stuff in between here. So the entire stack of how you structure the code for doing transformations and doing actions, and how that code is both written and packaged. Twirl takes care of orchestration, which I'll get into a lot, which means how it's run, how you monitor it, how you know if it breaks, how you handle retries, how you handle backfills, things like that. And then Twirl also takes care of the infrastructure to run all of this. So, and by default, for most of our customers, all the infrastructure runs within your cloud account. So like all compute nodes, all compute runs within your cloud account. Your data stores will live entirely in your cloud account, so data never leaves, your user data never leaves your cloud account, essentially. But you still don't have to manage infrastructure yourself. Any questions on any of this before I show you the product and talk more about details? Awesome. Then I will switch over and show you everything. Hello, hello. So let's start by jumping into our web application. So this is just to orient and give you a sense of what this looks like. This is a framework, or this is like the interface that you would use to see what's going on, or like get an overview of things. This is typically not where users would spend most of their time. You can think of it like it will look and feel familiar to interfaces of orchestrators like Airflow, that sort of thing. And it gives you an overview of what's going on. So like how things, jobs that are running, jobs that have potentially failed. Now, luckily, nothing has failed in this demo environment. You'll get cost breakdowns. You'll get detailed cost breakdown if you want. You'll get uptime graphs, etc. And then we also, of course, have the sort of mandatory pipeline overview. And the interesting thing here, I guess, is that this shows your entire data environment by default. So like there's no concept of like separate tags. Everything exists in one unified world, which is very powerful because then you can reuse functionality across the organization, but you can also get an overview of everything in one place, which is quite powerful when you get to scale. What I will show you today is one particular example that's centered around GitHub pull requests. So this is a little mini pipeline that is sort of a pretend example where we pull data from GitHub about pull requests, and we want to predict, we want to both track how quickly we solve pull requests and predict how quickly we will close new incoming pull requests. So we partly have some parts of the pipeline here that sort of ingest data and just build some reports, like we build a report about open issues here. That could be used in a BI use case, I guess. And then we have sort of a perhaps more interesting ML pipeline in this example. And each node here represents, by default, represents some kind of data asset, typically a table, but can also be a collection of files, for example. So most of these live in BigQuery. This example runs entirely on GCP. We also support AWS and Snowflake, of course, but so you can have interdependencies between tabular data and unstructured data or blob data, and it's sort of everything is represented in one unified framework. So each node represents a thing. Each node typically has some associated code, some job code that's responsible for updating and maintaining that thing. And in this case, the example is that we sort of, and this is one important aspect of a great platform as well, is that it lets you see everything in one place, not just your SQL transformations in in your warehouse, but also other things that are sort of outside of it. So in this case, we start by pulling data from GitHub using Airbyte. It lands in a table in BigQuery. And then we, in this case, use the sort of bronze, silver, gold medallion style architecture where we have a raw layer where we land data and we do ELT, so we clean it up a bit, and then we build features for our ML modeling. So features about each pull request, features about each repository, features about each user, and then also outcomes, historic outcomes, so like the closing time for historic pull requests. And then we have, it splits up into two different pipelines, one that does predictions. So this, for each new incoming pull request, it predicts, it uses the features and it predicts the in how many hours we will close that pull request. And then we have a separate pipeline that trains new versions of this prediction model. So was there a question?
Den här jävla...
Okay.
Sorry, I accidentally unmuted with my new headphones.
No worries. So this is sort of the example we will be looking at primarily, and the interface, like, of course, you can look at this in a graph view, you can look at it in a table view, you can get detailed information about each run, like, again, cost, run times, historic runs, everything you would expect, logs. But what I will show you now is what this looks like from a code perspective. But before doing that, we'll pop over to BigQuery and look at this, what it looks like in the asset view, sort of. So here we have the BigQuery console that shows the tables corresponding to the nodes in this graph. So each node corresponds to either a table or a set of files. Tables are structured in data sets or schemas, as it would be called in most other databases. So this is just sort of the data about pull request, or in this case, ML features about our pull requests. We're using the rough repository because it has a lot of action and gives plenty of training data. Switching over to looking at the code, or what this looks like, what it looks like to work with this kind of system. This is just my local editor, VS Code, so you can use any editor you like working with Twirl. You don't have to sort of stick to a web UI or anything like that. And this is the corresponding code. So the code is structured in the exact same way as the assets in your data stores. So in this case, the GitHub model tables are represented by directories. And similarly for files on GCS in this case, they are similarly in document or exist in the corresponding code paths, which makes it really easy to find the code that's responsible for each node. Each node is, if we start by looking at the job that builds ML features for each new pull request. This is a very trivial, the actual code here is very trivial, but this is a trivial little SQL script that just does some aggregations on each pull request. So it reads from the clean data and aggregates it. This is pure SQL. Like, you could copy paste this into the BigQuery console, no macros, no magic, if you don't want to, which can be convenient and reduces lock-in. And then you can also put a manifest in each of these directories if you want to, or like to specify more metadata about each node. So in this case, you'll see that we have defined a data contract for this table. So this is saying that this table should have these columns. Columns should have these types. You can also do things here, like you can have descriptions if you want to document your data and have it pushed to data catalogs. And you can specify inputs if you want validation on inputs. So like if this is a sensitive production thing and you want to be careful about what you depend on and how you change things. You can declare things explicitly. You also don't have to. So like if you don't care about contracts, you can just skip it. But we try to make it easy to maintain this. And then it's saying that this is BigQuery job. We'll execute on BigQuery. So most of this should be pretty self-explanatory, I guess. The nice thing is that this looks exactly the same if you want to do something that's not SQL. So if we look at the table that contains predictions, now we're doing these predictions in like semi-batch or mini-batch. But this is a Python script that does predictions. So in this case, it's a super simple little Python script. You'll see that it's pure Python. You don't need to import Twirl. You don't need to do anything magic. You don't need to add any magic annotations. This is just pure 100% standard Python code. And the only thing you need to do is you need to define a specific function that accepts input data in a certain format, basically standard pandas data frames by default. And then in this case, we extract some features, build some feature vectors, and then we load a previously trained pickled model from blob storage. We do some predictions, and we just return the resulting data frame, and that will be persisted into BigQuery. And this works exactly the same. So like you can still define the same kind of contract. You can still define the same kind of inputs if you like. In this case, it's a Python job. You can do things, and this runs containerized. So each of these jobs will be built into a separate isolated container. If you want, if we switch over and look into training job, if you want to run this with lots of memory, you can. So like, again, the infrastructure aspects of this are handled under the hood. So we try to have this design principle of basically, if you don't need to worry about these things, you shouldn't have to. So like, if you don't care, you'll get sensible defaults. So to make it more approachable for like less sophisticated users. But when you need flexibility, it should be available to you. I'll talk more about that in a minute. And then when you have modified your code and you want to test run it, the user experience locally is quite similar to DBT. Like you don't need to spin up some local server. You don't need to do anything fancy. You just type twirl run and it will build the table in a personal dev environment. So I get a sort of my personal copy of this table where I can inspect it, inspect my changes, and run tests, run unit tests, run validation tests, and until I am happy with it. So I guess in this case, let's do this. And then since I said that for this particular table, we have defined a contract, Twirl will also, in this case, tell me that live demos. Twirl will, in this case, tell me first that I made a mistake in my SQL code, but secondly, that I have declared this schema to contain a certain set of columns, but now suddenly we have a new column here, which is not intended. So if I think this is correct, I need to update my contract. We know how annoying it is to keep contracts up to date. So, but we also know how important it is to keep it checked in and keep it version control. So what we've done is basically, instead of making it optional, or like it is optional, but instead of making it sort of discouraged, we've tried to make it really easy to maintain it. So you can sort of copy paste the result if you think it's correct, and otherwise you'll find out. And now if you rerun, you'll see that this column will eventually appear in my personal dev version of this. So if we now reload this, it's so necessary. we now have a new column in my personal data set, but that's of course not in production yet. So if I'm happy with this, I will merge it, commit it to GitHub. Twirl has an integration with your GitHub or GitLab repository, and whenever you merge to your main branch, new code gets deployed. And so it's sort of a Git-based workflow for how to deploy to production. And this might seem like a pain, perhaps, but the reason why this can be powerful is like a common thing that might happen is that you have a column that's an integer, but then someone decides, I want this to be a percentage. This doesn't quite make sense in this example, but and divides it by a float, and this will work fine in a dashboard. Because dashboards typically don't care about types, but if you're consuming this in a downstream production system, things might break horribly. So if you specify contracts, Twirl can help you with things like confirming that you told me this was going to be an integer, but you're actually giving me a float. If that's correct, fix your contract. If it's not correct, fix your code. So then you can prevent production breakages before you deploy, which is nice and surprisingly unusual in data environments. Right, so again, code-centric, Git-centric workflow overall. Also nice because you get complete version control and a lot of predictability. And then just to show you sort of more advanced things, this was mostly pretty simple. The nice thing about this is, again, everything works exactly the same for code in other languages as well. So you could just as well run a Python job, you could run a containerized job, it will all run and work exactly the same. And you can test it all in a local, similarly isolated way. Some more advanced features. So one thing is that now we looked at very simple Python projects, just a single file, no particular dependencies. If you want to do more advanced things, we can switch over and look at another job that extracts data from PDF files. So this again produces a table with file names and the texts from the PDF files, but it consumes an input that is sort of a directory or a prefix in Google Cloud Storage, which is like S3 blob store. So whenever new PDF files land in this directory, we load them and we extract data from them. Again, fairly trivial example, but in this case we get the input in the form of files. We loop through them and extract some data and then return the result. But in this case, we're using a third-party library for parsing the PDFs. So then all you need to do is just add the requirements text file to this directory, and then Twirl will pick this up and use this particular requirements file to build the container for this particular job. So again, you don't need to learn any new way of doing things. You can use requirements just like you're used to if you're used to working with Python, and things will work. And also, if you don't know what a requirements file is, you don't need to worry about it because you'll get sensible defaults and it will most likely work the way you intended to. And then if you want to do very weird things, you can specify what we call a container job, which is essentially sort of anything that you can put in a container yourself. So this means that you'll get much less support and much less guarantees from the Twirl framework, because like there's less Twirl can do to help you validate contracts and validate your inputs and outputs and so on. But this is a very powerful thing when you need flexibility. So like if you want to do something that doesn't fit quite into the Twirl, like the sort of the safe Twirl environment with guardrails, you can easily just break out of it when you need to. And again, this is another sort of important feature of strong data platforms in general, is that if you design it to be very supportive and very opinionated, power users will eventually get stuck, like it's inevitable. And when they do, if you don't give them sort of an escape hatch, they will set up something on the side, or like do something outside of the system, and then suddenly you lose the nice overview, and you lose lineage, and you lose sort of unified tracking of things. So in this sort of contrived example, you can put a Docker file in a directory like this. So this will build a table called container Java ingest, which is, again, really contrived. But since there is a custom Docker file here, Twirl will use this, and this basically builds a Java project and runs a Java application. So this is a full-blown little JavaScript or not JavaScript, but a Java application, I guess, that connects to databases and extracts some data. Which again is powerful for when you need it. The other thing that I almost glossed over is that just like with tables, you can specify dependencies on file collections or like essentially folders, and more is coming on this front. So like you should also be able to integrate with streaming systems and buffers and things like that. Again, to be able to do anything you want in the same environment. I can go much deeper, but I'll save that for later. Another thing to talk about is that you may very well want to mix latencies. So for some pipelines in your system, it very well be enough to run things daily or hourly or weekly even, or monthly. Excuse me. So whereas for other things, you might want them to run quite often, more or less continuously. So in this example, this sort of machine learning example, we are running predictions. Now it's configured to run every hour. But so the sort of the prediction pipe runs often. But we don't need to run the training pipeline as often. Like we don't need to retrain whenever there's new data. So what we have done then, by default, Twirl works like it schedules everything to update whenever it needs to be updated. So like this node will run an update whenever there is new input data, and it will never run unless there's new input data. So that basically means that by default, you can determine how often you load data into a certain source, and then let everything else just run whenever it needs to. So if you load this data every 24 hours, all of this will run every 24 hours. If you load this every 5 minutes, it will all run every 5 minutes. And you sort of, by default, don't need to think so much about it. But again, if you want some parts of this to run less often, which you may want to for various reasons, you can specify limitations on this. So like in this case, we have specified what we call, let's see where we are. Let's see here. So we specified what we call a trigger condition. So in this case, this node that trains a new machine learning model is configured to run when all inputs are updated, but at most every 24 hours. So even if there's new data on all inputs, it will not run more often than once every 24 hours. And you can also configure warnings to say that if we will check every hour, we will check, and we will ensure that this data is not older than 1 day. And if it is, then this will be marked as stale, and you will get notifications on Slack. So this means that basically you can have one pipeline that clearly shows all dependencies, but you can have different parts of this pipeline run on different frequencies or different cadences, which is quite powerful, because it's a very, like, again, DBT introduced this idea that like batch is very simple and very, very convenient. But that sort of makes it, when you want to take the step to low latency, then you typically need to like re-architect things quite dramatically and switch to like streaming systems to get those kinds of guarantees. But with good data platform, you should be able to sort of seamlessly make that switch. So like if I want to change one pipeline to run more often, I should only have to make small tweaks, and that should not affect the rest of my pipeline. And I still want to see everything in one graph. Like I don't want to have separate DAGs that have implicit dependencies, and worst case, maybe even cron dependencies. I want to be able to see lineage. I want to be able to test things. I want to be able to get warnings if I'm about to break things, and so on. So being able to mix different latencies is sort of also a very powerful thing to have. I think I'll stop there. There's lots more that I can show if there's interest, but just to pop back to this. To recap, Twirl is sort of, or a great data platform should not limit you to just one data store. It should not limit you to just tabular data. But it should also give you a nice, convenient developer experience. Like, you shouldn't have to worry about if your code runs in a warehouse or if it runs in a container. You shouldn't have to worry about if you're depending on tabular data or unstructured data. You shouldn't have to worry about if you're like calling external APIs and waiting for timeouts, or if you're just running things in a warehouse context. And this is quite powerful. As a little sneak peek, sort of an interesting side effect of designing a system like this is that the Twirl transformation framework that I just demoed to you is sort of a pure transformation layer feature. It's entirely disconnected from our orchestration layer, which actually means that you can completely seamlessly and without having to specify any configuration code almost at all, you can also have the same system orchestrate your ingestion services and orchestrate your dbt jobs and orchestrate a lot of other things, as long as they all work with the same underlying things in your data stores. We will have more to say about this soon, but sort of as a side note, that a platform like this offers you a lot of flexibility, both when it comes to choosing what tools and what cloud services you want to use for your data processing, but also when it comes to choosing the frameworks you want for managing Codon transformations. So that's sort of the recap. That's it. There is more to data than just what happens in a data warehouse, and that can get messy and can get hard, but it really can be delightful, and if you do it right. So that's what I had.
Thank you very much, Eric. Thanks for a great presentation and demo. Yeah, do we have any questions from the room? Frederick, go for it.
Yeah, I was wondering, I mean, thanks for a great talk. Really good. I was wondering if you could show us a little bit about, or talk a little bit about the documentation. For instance, I thought the best documentation that I've seen so far has always been like MATLAB documentation, where you go through, where they show the theory, they show enough so that you can make a, you know, get a really good idea about how to set different arguments if you're not an expert.
You mean the documentation for Twirl itself?
Yes.
Yep. So yes, we do have a lot of documentation. I'm not sure. Right. Quickly show what it looks like. So we have a documentation site for customers. So this sort of contains everything from getting started guides to more detailed guides about how to do certain things, to advanced concepts about, you know, how you manage secrets in a good way. Twirl also nudges best practices when it comes to like how to handle secrets, how to handle connections, how to handle network, like all the sort of annoying, complicated stuff. So yes, we have a lot of documentation. I don't know if you had any specific question, or did that answer your question, I guess?
Well, it's good to, it's just interesting to see. Thank you.
Yep, for sure. I can show you more offline.
Cool.
Any other questions?
Yeah. Had another question. I was wondering if you could say something about, like, let's say you do make a change in one of the scripts and you want to compare before and after. If you could talk a little bit about that.
Yep.
So you might want to go back to a previous commit and want to see how did this affect the data and how much should you store, etc., etc.
Right. Yeah. So we have functionality coming up. I don't have anything I can demo, unfortunately, but yes, we have functionality coming up that allows you to basically sort of diff data and track how changes impact your data. Today you could use extra, like there are lots and lots and lots of separate systems for this. Like my personal favorite is probably Datafold, and closer integrations are coming. Any other questions?
Thanks for a great presentation, Eric. I was wondering, like, from a business perspective, how do you sort of position Twirl? Like, is it something that should replace solution X or be a complement to solution Y? Or can you talk a bit about like alternatives, competitors, and how you?
Yep, for sure. So we like to say that the sort of Twirl is not just an orchestrator, but it is an orchestrator. So like fundamentally, it serves that purpose in the stack. It does more, but that's the primary position, which means that it sort of it does not replace things like DBT or transformation layers. It can and should integrate seamlessly with those things. It can coexist with other orchestration solutions, but you'll get the value if this is your solution for orchestrating and executing your code.
Right, so not just an orchestrator. Yeah, it's always good to have a catchphrase.
Yeah, I got interesting advice that like if you find yourself telling people that we're not just an X, then you actually are an X. It's good to remind.
And the example you showed now was, I mean, it was based on BigQuery and kind of the Google infrastructure, but I suppose that you have sort of equivalent hooks into AWS and Azure as well, or?
Yes, Azure not yet actually, but
Okay.
AWS for sure. So AWS, Redshift, Snowflake, all works, and it's like Twirl is designed to be very pluggable. So we also have support for other both compute platforms and storage platforms in various levels of maturity, like Apache Beam, Dataflow for compute, and even Google Sheets for storage if you want to do weird things. Yes, Fredrik.
I was a bit confused about how much is drag and drop and how much is writing code. If you could...
Basically, nothing is drag and drop. So that's another thing that we believe strongly is that it is like the right granularity you need. Like the level of granularity you need to build an system is the granularity you get from code. So you'll end up needing to express it in the form of code at some point. And it's much better to make it easy to work with code rather than to try to hide it. I think we are in the camp that believes that this will evolve like web applications did. Like drag and drop has its place, but if you want to do something that's like reasonably advanced, you will prefer Next.js over Squarespace.
So sort of not like Matillion, for instance.
Correct. Yeah, exactly. So it's very code centric. Of course, like the evolution here is, of course, to like right now you need to be able to work with Git. Of course, we'll abstract that away at some point. You know, maybe add a web editor. But today, the web app is almost purely read-only, except you can trigger runs.
Cool. Do we have any more questions? If not, then yeah, thank you, Eric. Thanks for yeah, as I said, great presentation and cool demo. Yeah.
Yep, very happy. Happy to be here, and thanks for good questions. If you're curious and you want to hear more, if you want to see more details, if you want to just talk data, please reach out. You'll find me by my name everywhere, or email me at eric@twirldata.com.
Great. Thank you very much. Cheers, everyone.
Bye.
Thank you. Have a lovely Friday and a great weekend.
Thank you.
Nice weekend.